Hello, let me explain the measuring force experiment. In this experiment, we're going to measure two different forces, and we're going to learn how to measure these two forces with two pieces of very accurate and very sensitive equipment. Okay, so the experiment is to measure tension and normal forces. So first of all, equipment safety. Both pieces of equipment are very sensitive, and I want you to handle both of them very gently. Gently take them out of their containers, perform the experiment gently, and when you finish, you gently put them back into the containers together with the every piece that you take out. So first are theoretical pre-lab questions. So to ask you what should be the tension force. If you suspend a 100-gram mass from a spring scale using a piece of string, what should be the tension force? Okay, so this is to convert a mass to a tension force, and you convert the mass to weight. That is 0.1 kilograms, first converted to SI base unit, and then in this case, that is 0.1 kilograms times the gravitational acceleration, 9.8 meters per second squared. There you can calculate what it should be. All right. And so here, let me introduce you to our very sensitive, very accurate spring scale. Our spring scale has a range. If you read on the left side of the markings, it's from 0 to 1.0. And the unit on the top, you can see it's Newton. So the range is 1 Newton. Okay. The accuracy is between two consecutive markings. Between 1 and 0, there are 5 markings. So each one is 0.01. So this scale is 1.0 Newton range and 0.02 Newton accuracy. Okay, so what you can do is you can hand a piece of weight that's 100 grams or 50 grams or any other object that is not more than 1 Newton. And you hand it at the bottom, and then you are going to read it and upload the image. So this is the first measurement we introduce. Measure tension force. Tension force also means pulling force using a spring scale that has a range of 1 Newton and 0.02 accuracy. Second, 100 grams on the platform scale. Well, it should read 100 grams. And you can also convert 100 grams to newtons. After that, we're going to make a measurement. We are very lucky to have this electronic scale. If you look at the printing on the box, it's 100 grams. That's the range. And it's 0.01 grams accuracy. So 1/100th of a gram accuracy. So this is a very accurate, very sensitive scale. So when you place an item on it, I need you to please place on it gently. When you remove, you also remove gently. When you hold it gently. Okay, and you make a measurement, take a picture, upload. The next part of the experiment, you need to use an elevator. Then you might ask, what if I don't have convenient access of an elevator? All right, so as a matter of fact, we can create a simulated elevator. We can do simulation. What does that mean? You ask somebody to help you hold the scale, move it up and down. If you have to move anything up and down a few times, you are definitely going to have to accelerate. That is the effect we need from an elevator. We call it an elevator. So it can be a real elevator or it can be a simulated elevator. So that reason, we still call it an elevator experiment, and we can have it in different ways. Okay, so what you want to do is to take this tension force experiment, right? Instead of having it at rest, we're going to make it, take it into a moving elevator. In a moving elevator, you want to see how the reading changes. Is the reading going to become larger or smaller? And if possible, take a video and upload from your video or your observation, figure out the maximum acceleration of the elevator. Let's discuss this in the discussion part after you upload. And take the platform scale also into the elevator, either a real elevator or a simulated elevator that you, and then observe how the measurement changes when the elevator moves up and down. I would like you to make the elevator, make the measurement at least 3 complete cycles. That means if you go up, come back, up, come back, up, come back 3 times and observe how the reading changes. I'd like you to take a video if you can, or a photo, and upload into discussion. So in summary, in this experiment, we introduced 2 measurements. We are very lucky to have these 2 very accurate and very sensitive measurement equipment that allows us to measure the tension force with a spring scale and the normal force with a platform electronic scale. So that's today's experiment. This experiment will help us understand these 2 forces and will help us to be prepared when we move on to next chapter, which is the most important chapter of this course. That's Newton's law.